Alright guys, so I wanted to hop on here and go over some of the problems on this assignment with you so you can have an idea of how to solve these, just in case you were a little still fuzzy on how to calculate population growth rates, even after watching those Bozeman videos. Okay, so those are still out there for you to be able to look back at to help you if need be. So I'm going to try to get a couple from each little section. So the first one I'm going to look at is number 1 under the population density practice problems. It's pretty straightforward on how to calculate population density. It's like how you would calculate density in your chemistry classes and things like that. And so here in this situation, we have 300 blue jays that are found in a 200 hectare. We want to figure out what is the density for my blue jays in hectares. So we have 300 blue jays. We would divide that by 20 hectare plot. Simple math right there. Going to calculate to about 15 blue jays per plot. Okay, so pretty straightforward. And so 2 and 3 pretty much go around the same thing. You just have to, it won't be hectares, it would just be kilometers squared for each of those. Okay, so you'd have to calculate that area first before you divide. Okay, moving on to population growth problems. I want it to, number 4 is pretty straightforward of what's going on there, but I want to go over number 5 because it is split into multiple pieces, and that sometimes scares us. So in a population of 600 squirrels, what is the per capita birth rate, or the per capita birth rate in a particular period is 0.06, and the per capita death rate is 0.12. Okay, so question A is, what is the per capita growth rate of the population? We're going to round our answer to the nearest 100. So we're going to use the information that they've given us, and so we're going to go R. So I'm going to have to zoom in just a little bit because y'all know I write kind of big. This way I could adjust my handwriting. So it is going to be my birth rate minus my death rate here. So my birth rate was 0.06 minus that by my death rate, which was 0.12. It's actually going to give me a negative number. Negative numbers are okay. Okay, don't get scared by negative numbers. And this could be negative 0.06. So that tells me that this is not looking good for these squirrels if they are dying faster than they are birthing out squirrels. Okay, so B here is asking what is the actual number of squirrels that die during this particular period. Again, we're going to round our answer to the nearest whole number because we can't have just part of a squirrel. I am going to use my death rate equation. We're just going to have to rearrange it just a little bit because we already have my death rate. We want to know how many actually have died. Okay, so it is going to be D equals M times N, which is the number of squirrels, or the number in the population. So that's going to equal 0.12 times that by my 600. Is going to give me 72 deaths. Okay, so let's look at C. What is the actual number of squirrels that were born during this period? Again, we're going to use my birth rate. We're going to have to rearrange that equation just a little bit because we know the birth rate, but we want to know how many squirrels were actually birthed during this time. So we're going to use capital B equals lowercase b times my number in the population. So 0.06 times 600 is going to give me a whopping 36 births. Okay, so as you can see, way more squirrels are dying compared to what is actually being born. Sad. Okay, I'm going to move right on along here to our next section. If I could get this to go, because it is not going. There we go. All right. Survivorship and mortality rates is the next section there. We're going to focus on number 8. Okay, so survivorship is just like it sounds. It's going to be the organisms that have survived. And mortality rates are those that did not. Okay, so number 8, talking about some rats here. It says, suppose that a cohort of 200 rats in a rat colony born in January. We have 160 are still alive at the start of March. We have 120 are still alive at the start of May. So again, we can see that our rats are dying off. So question A is asking, what is the survivorship up to the start of March? Round to the nearest 100. So what we have to do is we got to see. We had 160 that were still alive at the start of March out of my total original starting point, which is 200. So in this case, I'm going to have 0.08 as my survivorship rate from January to March. Okay, it's going to fluctuate a little bit for B. We want to know what is the mortality rate from the beginning of March to the beginning of May. So now we want to figure out how many of these guys have died. So we're not going to just go 120 divided by 160. We've got to see how many have actually died. So I would have to go 160 was the start of my March minus 120, which was the start of May. That gives me 40 rats that have died divided by my original starting point, which was 160. So that's going to give me a 0.25 mortality rate here. Next question, it says, if the survivorship during May is 0.3, how many rats died during the month of May? Okay, so what we're going to have to do here is go with how many rats did we have at the beginning of May, which was 120. Multiply that by my survivorship rate that they just gave me, which was 0.3. That's going to give me 36 rats that survived. But what we want to know is how many died. So I'm going to have to go 120 minus those that survived, which was the 36. And that's going to give me 84 dead rats. Okay, so that's how you would calculate those there. There we go. The next set is going to be population studies. And so I'm going to do the population A alongside with you to give you population B to do on your own. Okay, so our situation here is we're going to be calculating the stuff in this chart. Okay, so it says you and your friends have monitored 2 populations of wild lupine for 1 entire reproductive cycle, so June year 1 to June year 2, by carefully mapping, tagging, and taking a consensus of the plants throughout this period. You obtain the data listed in the chart. So here's the chart that they give us. So they tell us population A, my initial number of plants is 500. The number of new seedlings established is 100. Number of initial plants that die is 20. Okay, so we're going to be using that information to calculate right in here. So calculate the parameters for each population. So B is the births during this time interval, so that's going to be 100. D is the deaths, which is going to be just 20. My lowercase b, my birth rate is going to be 100 divided by my starting number of plants, which is going to be 0.20. M, which is my death rate, is going to be my number of deaths divided again by my starting population, and that's going to give me 0.04. my R, which is my per capita rate of increase, is subtracting my birth rate from my death rate. So 0.2 minus 0.04 is going to give me 0.16. Okay? So using this information here, you're going to calculate the same thing for population B. Okay? And then you could be able to figure out the rest of this as we go along. Like I said, feel free to reach out to me if you need some additional help with these problems. If you want to continue working through these problems and answering them on a Google Doc, you're more than welcome to do that. I know some of you are more comfortable with just using your own separate sheet of paper and uploading your assignments, and I am perfectly fine with that as well. So hopefully y'all are all doing well. Like I said, reach out if you need help with these. Just wanted to go on here and walk you through some of these problems just like we would in class. All right, have a nice one, guys.